Hello everyone, it's Peter. I will start a sequence of a series of special topics for some very useful tools or concepts in the real industry. So I will deliver several sessions for special topics. The first one I want to cover is called Resilience 4J. Resilience 4J. Here's the introduction. Resilience 4J is a fault tolerance library that takes care of external service call. Okay, when we talk about the fault tolerance in the core Java world, in the purely Java world, we do have the fault tolerance framework called exception handling. We can use try catch to catch any exception happened during the code processing, okay, during the code, running time. But for some special cases, the try catch is not good enough. For example, if I want to call an external service, that is, I want to build a REST API, but this REST API will call another REST API. For example, we want to deploy our REST API on AWS. So we want to call that API. So there are lots of different cases. For example, if there are too much calls to that API, so it results some delay. So it will have some heavy traffic, or sometimes the server is down. There are different scenarios. You cannot simply say, "Oh, try catch." If there's any exception, I just catch it and I just give a log saying, "Oh, this server cannot be connected." That's not the correct case. So because you need to have retry, you can have like after 10 seconds or 5 seconds, you can get a retry. Maybe next time you can connect it because after a few seconds, the traffic is low and then you can connect it. So there are different cases. So here I explain that different from exception handling, resilience 4J means miscellaneous scenarios from external services, such as non-consistent behaviors. So sometimes it's connected, sometimes it's not, right? It's non-consistent because and the connection timeout, traffic limitation, etc. Right? So this is a website. If you want to go to read the detailed document, you can go to this website. And if we want to do the resilience 4J, we need the following requirement. Right? We need AOP, actuator AOP, and the resilience 4J. This one in Spring Boot. Now, in Spring class, we talk about AOP. We gave a very simple concept and small examples of AOP. So usually in industry, we didn't write a lot of AOP code by ourselves. Usually we apply some libraries which used AOP. Good example is Resilience 4J. Resilience 4J, they use AOP. Built-in libraries in their they have built-in AOP in their Resilience 4J libraries. Okay. Now, next I talk about the 4 modules in Resilience 4J. There are 4 modules called CircuitBreaker, Retry, Rate Limiter, and Bulkhead. What is CircuitBreaker? So this is a scenario. If an external service has a high failure rate during a period of time, that is, you connect 10 times, it failed half of the time, like 5 times it failed, and 5 times it's successful, or 6 times it fails, and 4 times it's successful. Okay, that's a high failure rate during a period of time. Then a circuit breaker will stop any further call of this service to reduce the network traffic. That is, if the traffic is very high and it results some connection timeout, and then you don't need to call it again. You can the call will be blocked for this service. This is called circuit breaker. Circuit breaker has 3 sets called closed, open, and half open. We've basically called about closing and open. It's like a circuit route. So if it's closed, it's connected, right? So if it's closed, if it's open, it's disconnected. So initial status is closed. After a failure rate reaches the specific rate, it will be open status. And after a while, it will be closed again. Okay. Open status you can set out like you will ask for like 1 minute or 2 minutes to make it open, and after 2 minutes it will close again, go back to the normal status. The half open is the prepare to be closed. It's half open. Okay. This is circuit breaker. Retry is easy to understand. If an external service might be temporarily down or has a temporary failure, it's a temporary failure. So retry can access this service several times and may fix the temporary issue automatically. So that is, you retry several times, like 3 times, 4 times. Then maybe if you are in good luck, and then you can connect it. So this is better than try catch. If you have an exception, you use try catch, then your own program will go through and will say, oh, this service cannot be connected. But that's not true, right? Because you can try by a later time, and then it might be connected. So this is retry. So sometimes we can have CircuitBreaker and retry work together. Right? First, we can retry. If retry several times is failed, then go back to the upper level to the CircuitBreaker. Right? If several retries is still fail, then we'll go to CircuitBreaker. We'll stop the call for this service. Okay. Now, next tool is rate limiter and bulkhead. Rate limiter is will limit the number of access to external service during a period of time. For example, during like 10 seconds, I only limit like 20 access to this service to prevent the heavy traffic. So you can define the rate of the how many calls you can limit in the rate limiter. And the bulkhead is to limit the concurrency. Sorry. Is to limit the number of concurrent access to an external service during a period of time. So this is different. So rate limiter is the number of access. It may be concurrent or not concurrent. So it may be one by one during a period of time, like in 10 seconds, and it will call one by one. But bulkhead is to limit the number of concurrency. So some service may have some limitation of concurrency access. So you have bulkhead to limit this concurrent access number. Okay, so there are two ways: is semaphore bulkhead and a fixed thread pool bulkhead. Fixed thread pool, we already mentioned that is you can define like how many threads you can use in executor services. So, for example, you can define 5. Then at most there are 5 access to this service at most concurrently. And the semaphore bulkhead. Semaphore is the number of resources you can define. This can be flexible. Okay. So this is just some concept. So in our code, I will focus on the CircuitBreaker and the retry. If you want more examples, you can try rate limiter and bulkhead by yourself. Okay, and then let's move to our example. I already have this example called name services. So where's the this guy. So first, let's check the application the YAML. Okay. So this is a name services, and then this is the I found a free REST API from website. So this is the website. I call this one. Okay. Then you can use question mark. Is the query parameter name equal to Alice? And then you return how many name is called Alice, and what's the count, right? What's the average age for this name? So then you can find something else. You can say, if I say it's Jason, this name, this is age, this is count, this is average age, this is count. So this is a free service. This is a free service. My service will call this service. But I don't use the question mark. I don't use the query parameter. I use the path. Okay. So if I run my code, I just need to run my code and show an example. If I run it, let's wait for a while. So it started. So what I run is localhost 8080 name. Let's say Bob. So this will call this service. This is Bob. Age count is the same. I simply call another service. Now in this example, I will introduce some good tools, good things in the industry. Okay, let's go ahead. So number one, the other is the same. This is a typical Spring Boot application with the name, with everything, and the login part. Now this is the circuit breaker and the retry configuration. This is resilient48.circuitbreaker. So the naming convention is fixed for resilient48. So as in the AOP, So it will read those numbers, those features. So let's talk about resilience 4J. We can skip the health indicator. So this is a buffer size in closed state. So that is, what is the buffer size? That is, you want to try how many times in this buffer? Maybe 3 times, 5 times. So totally, I need to calculate the rate. The rate is how many times fails and compared with the total time, right? So this is the number of the total time, right? So you can try 3 times, and the ring buffer size in half open state is 2. Half open state means that it failed. Either it failed is in the half open state. So totally the buffer size is 3, and it allows you if it reaches this rate. Sorry. Sorry. I didn't talk about this. This is the half open state. That's a different story. This one we can skip this. We just say this is ring buffer size in closed state. Closed state is connected. So there are 3 buffer. Buffer size is 3. And then the failure rate threshold. The failure rate threshold is 50, which means 50%. Like 3 times, if you failed twice, it's over 50%. It's 2/3, right? So if you fail once and connect twice, then it will pass. Right? So if the failure rate is 50%, then it will be in CircuitBreaker. It will become the open status, and it will have recorded exceptions. So because there are lots of exceptions, you may have exceptions from the external service. You may have exceptions by your own, like non-format exception, illegal state monitor exception. So those runtime exceptions by core Java itself, and some exception is from the external service. So this is my the name exception is what I defined my customized exception. So this is a default one, and you can have lots of circuit breakers. So this base config is default. You can also override. So if you want to change, you can override. This is a basic one. So for your own common breaker, you can use default one. You can call to the default one. Okay. And you can, if you don't want the default one, you can override those values for your own. Okay. This is a circuit breaker, and this is retry. Retry the default config, and this also instance is common retry is called config. So max retry attempt is 2. This is for testing purpose. In the real industry, you may have 5, right? Now it's only 2. Wait duration is 100. It means I will wait for 100 milliseconds, and we'll have another retry. And the retry exception is all for the this is all from the external service. Okay, so external service may have the socket timeout exception, may have resource access exception, so limited resource access, or may have HTTP server error. So if you send some payload and then there's an internal server error, so this kind of exception will have retry. But the other exceptions, I won't have any retry. Oh, I forgot one thing. So in this circuit breaker, there's a wait duration in open state. That is, if you failed, if you reach the fail rate like this, 50%, and then the state will be in open state. In the open state, you can wait for 50 seconds. After 50 seconds, you will back to close again. Okay. We will make a test for those things. Okay. This is a configuration for resilience 4J. Now let's go to our code. This is config. So here we use name properties. We mention this in our Spring IOC. So we can use prefix in the name. So you can see the application of YAML. Name prefix with the gateway, read timeout, and the connection timeout. Connection timeout, the 3 things. Gateway is the URL, what I want to call, and read timeout and connection timeout. So name properties with the gateway, read timeout, and connection timeout. So you don't have to manually create this bin or inject this bin. So it will read the bin from the application of YAML. So this is what we learned before. And then in the name config, we have name properties. We can auto-wire the properties with component scan. Those are what we learned before. Now the important thing is we use REST template. Do you remember when we do the integration test, we use REST template? So let's have a review of this one. In the EMP services, we can switch to the testing code. Okay. So in the test, let's talk about the integration test. So we used this before in this one. This is called test REST template, right? Test REST template. So this REST template we can get for entity based on the get request or post request. We can get for entity, post for entity, and so on, right? We already made those things. Get for entity, post for entity. This is for test REST template. But if we don't use test, we can run it directly. This is just a REST template. That's the same thing. Now let's switch back to 2.0. Okay. Just have a review. This is nothing new. Because we want to call another REST service, we have to use REST template. So we create a REST template with a name. We might call different services. We might have different REST template. So we just give a name. So in the future, if we have multiple REST templates, we have used qualifier to identify which is which. Okay. Now, this is how to build the REST template. It's builder. Okay. Default one, this is to read the gateway. That's the URL, the root path. And then you can set timeout with the get timeout, get read timeout, and the connect timeout. So you can define the two timeout to see what's the timeout. So here, I make timeout as 100 milliseconds. Okay. You can define more, like 1,000, like 1 second or 1,000 milliseconds as a timeout. This is name config. We define this REST template. Now next, let's go to the service side. In the service side, so we auto-while this REST template. So then in this code, we have find by name. First, let's forget about the retry part. So let's find by name. So this is log. This is URI. URI is we already have URL defined REST template. We just need to add URI. So get for entity with URI and name response. This is the same as what we did in the integration test in EMP services, right? We read it, we get a name response. The name response is to match, okay, to match this result. The result is in JSON format, so we can define a model which matches this age content name. So this is the age content name. So this is the name response. Okay. Okay. So we get this one and we return this get body. So this call might result any unexpected exception. Looks like it could be the timeout exception. It could be the server error, could be anything else, right? So then we have retry. So retry is annotation. So we don't have to write a lot of code after we define this all the configuration in the application YAML file. So we just use annotation. We just use annotation of this retry. So if it fails, and it will retry second time, third time, the first time, second time. So we can retry twice, right? So we have 2 times of retry. Max retry time is 2 times. Okay. Then after that, if it still fail, it will go to, it's called a fallback method. If it still fail, you go to this method. Be careful. This method should have the same method declaration, except it has one throwable, because this find by name will have exception. So we add a throwable. Others must be the same. The response, the return type, the find by name fallback is the fallback method you can define here. This find by name fallback is this find by name fallback, and the parameter this string name is this string name is exactly the same. Okay, then we just need to add throwable. This is the definition of the throwable. Because why we have to strictly define this method? Because of AOP. AOP will tell you when I inject some method, what will happen, right? So we need to have this one. So this actually is the style of AOP. Yeah, AOP, when you execute, when you use inject some function to some method, right? In this method, after I throw, I believe the AOP is the after throw. They are after returning or after throw, right? This is after throw. After throw, we'll go to this method, give this method, and then we have a log error message, and then fallback from this this URL with the message, get the message. Then I throw new name exception to the upper level. To name exception, I give the what's the exception name. This is the upper level. Now next. This setter is for testing purpose. Okay, I will talk about it later. Now next, upper level is the controller. In the controller, I have CircuitBreaker. So CircuitBreaker will get exception from the lower level if you call the service find by name. If you get the name exception, I go back here. So for the resistant 4J, it only react to this, for circuit breaker, it only react for this name exception. Other exceptions, it will forget about that. For example, if the lower part has like a number format exception or some other exceptions, don't worry, I won't invoke the circuit breaker, but the name exception will invoke the circuit breaker. Okay. Now, this is how the code is pretty simple, very straightforward. Let's go to the service and this controller. So this is a controller class we'll call service, and this service we'll call the external service, right? Use REST template to call the external service, and it will have a retry here, and the upper level have circuit breaker. Circuit breaker and the retry cannot be applied for the same method. It has to be applied for different method. Be very careful. Circuit breaker and retry cannot be applied on the same method. So one method is the retry, and the upper caller will be the circuit breaker. That's the combination of the two resilience 4J modules. Okay. Now, next, how to test. That's another big topic. How to test. I already have all of them. Then how to test. Let's go to the test part. What we learn is mock MVT test. So this is a mock MVT test. Okay. So we have this REST template. It's a mock bin, right? It's a mock bin. So we go to this level. This is what we learned before for the mock MVT test. Test by name. So we have request URL, and when this happens, when this get for entity, so now we learn something new. Because this get for entity, the first one can be any string, the second one is a fixed value. So you cannot say anything. So because this one you have to be equal. I use argument matcher. Argument matcher. So this is like, for example, I want to mock a method called foo, right? Foo with intn with a string str and something, or with something class. Okay, with some class. Some class. I don't say class, okay. I just use this example. But the method call is I just call this one for 5 ABC. Okay. Now how do I mock it? So usually we can use mockito.any int, right? So we can use full of mockito.any int, right? Mockito.any string, right? Usually we can do that, but sometimes this is a fixed value, it's not ABC. Like what we have is, let's go to the this one. So this is a name response class. This is the class, class, right? This is class. So this one is a fixed value, and this one, the URI can be any value. So if we use say, oh, this one I want to use ABC, this not working. Okay. If you use any like the wildcard type, you have to use all wildcard type. Or if you have a fixed value like this one is ABC, then it cannot work. So how to make it work? The correct working is that the first one you can use any, is the wildcard type, and the second one you can use argument matches. This is called. Let's write this one. This is what you need to learn. So argument matches dot equal ABC. Then this will work. Even int, you can also use argument matches any int. You can also change to this. You don't use Mockito. I strongly suggest you to use argument matches. Argument matches is more flexible, and it can also equal to null, right? Sometimes you have null. Now, if you use null, then any string, Mockito any string will not work because null is not a string. Null is null. Right? So this one, if the input value is null, this test is like null, then Mockito any string will fail. Okay, so you can use argument.eq now. Okay, so argument provides more flexible wildcard or exact match in the parameter in the Mockito. This is very important. So this is a small tricks in when using the Mockito. Okay, let's come back. Now, others is the same, right? So I perform and verify those things. I create some age, some dummy data, and then I can run it. Yeah, let's run it. Now it will work, right? So it's working. So this is not a surprise. So this is mock MVC. But the thing is, how do I test retry and CircuitBreaker? Because I want to simulate different scenarios. Like I want to simulate the timeout. I want to simulate the server error or some other cases from the REST template. So then mock MVC is not good enough. It's not good enough to test those cases. Although it can do test, so to build a scenario is very difficult. Use REST template, but now we have a different tool, another framework called WireMock. Okay, so next I will introduce this one, WireMock test. WireMock test is a supplement of the integration test, and but it has its own target. WireMock provides an efficient way to test external services, especially for external services. For others, for the normal code, you don't have to use WireMock, right? So external services testing, WireMock is a good choice. It can simulate different scenarios. There's a typo. It can simulate different scenarios for external servers, such as server internal error, socket timeout, and etc. In the WireMock test, a mock server needs to be launched before the test and stopped after the test. And it provides good way to test the resilience 4J. Okay, I just give a summary, and I will show how to do the WireMock. WireMock in the POM, you need to add WireMock the dependency. Okay, this is WireMock dependency. This is the version. You can go up to find the version. So it's only one dependency. That's good enough. Okay, then that's the first thing. The second thing, let's go to the WireMock. Okay, so let's go to the name controller WireMock test. Let's go to this test. So after it's same, so you auto wire test REST template is same. Then we have a WireMock server. Okay, we have a WireMock server. We have name service template. The reason is that our REST template is different from the from this config. This config we configure the real API. I configure the real one, real URL of the external service, and then the WireMock server will define mocked URL, a placeholder, and related to WireMock server. Okay, so let's see this setup. So this is the gateway URL. Then it will change to HTTP localhost column with the port, right? So first we have a new WireMock server, and I start the server first. And after the test is done, I use teardown to stop it. So I set up, and there's a teardown. And then after I start it, I create a name REST template here, and others is the same. The read timeout is the same, but the template URL is new default URL built is gateway URL is this one. This is not the real one. This is the fake one. This is related to WireMock. Right? So then I use setters. I will replace the REST template with the mocked one, with not the real one. And CircuitBreaker. This is I need to use this one CircuitBreaker and use registry. This one. This is useful. I will talk about later. Okay. Now let's call about the test get by name. Get by name. So it's like mock, but it's not called mock. It's called stub. It's stub for. So it's like WireMock get. It's called get request. The URL is equal to this name equal to Alice to this URL, or you can go to any URL. So I just give an exact match. We'll return this is OK JSON. So you can build a response. Okay, build a response is here. Wait. Okay, if you open it, build a response, you first build a response here, and you convert it to a string, right? We use object mapper. So this is what we learned before. Build a response. So this is similar, but with different grammar. This is WireMock, not Mockito. Mockito is also we get a response. If we go to this this test, you will have market when this happens and get anything, then will return build response. And this is the WireMock. If it get this request with this URL, will return this build response, but with the string format. Now we have request URL, and I use REST template to call this, and then the site code is okay, and everything I confirm that. This is a normal case. This one has no relation with the retry and the circuit breaker. Okay, so this one I can make a test to make sure it can work. So it work. It's not working. Fatal startup. Oh, so because I use 8080, so WireMock by default, I use 8080, but I need to stop the previous one because okay, in the console. Okay, in the console, this one I didn't stop it. So 8080 is already occupied, so I need to stop it. Let's stop test timeout. So this is the test run name. Then let's run it. Okay, this should work, right? This should work. Now, next, let's test the socket timeout. So this stopping, so WireMock will get the same thing, will return, and then after we get response, but we have fixed delay of 200. If we go to this one, the timeout is 100, right? The connection timeout is 100, but the I delay for 200 for the test. So it will return a socket timeout. And after that, this will have internal server error because it will throw the name exception. The name exception will finally go to the front end, and then this is socket timeout. Yeah. So because this one cannot be simulated by mock MVC, so only one mock can use the with fixed delay of this one. So this one is good. Okay. So you can see now I will tell you about what the retry. Okay. Find age information by name and find age information twice. Then go to the fallback. Then let's come back to the code. If we go to the code, go to this service code. If the timeout happens, so in the retry it will catch this exception and then we'll call this again. So debug will happen twice because the max retry is 2, right? So if we go to this one, the max retry number, the max retry attempt is 2. So it means that so this function will call twice. After 2 times, it will also fail. It will move to the file name callback. So that's what we can see in the console. So receive request. This is the first receive request. Then the first time I find the age of this one, and then it request handle class. Then find the age again. Okay. Then 2 times it also both failed. The max retry limit is reached. Then we go to fallback. Fallback from this one, and then it shows. It shows from this local read timeout, right? Read timeout. So it has a timeout exception. Okay, it's a read timeout. So then the retry happens. So this test also proved the retry. Okay. Now this is socket timeout. Next is a server error. The server error. So here you can see before and after because we have error, so we have to do the reset. The reason is if you only run this test, it's fine. It's totally fine. But if you run all together, if you do a Maven build, so you may run lots of cases. And every time if you don't use reset, so the circuit breaker will be in open state. And when it is in open state, and other tests may be infected. So it means this test may infect other tests. It may result this common circuit breaker open. And even the normal test, like this test by name, may fail, might fail. I think this is what I believe by my experience is a disadvantage of WireMock. So each test case, if you really have the retry or circuit breaker, you have to reset the common circuit breaker. Otherwise, if you have many exceptions and even you handle it, and the circuit breaker may be open. that will result a big issue. So it means that the single unit test, like one test case, you may be success, but if you run all, it will fail. Okay, so I especially I want to add this one. This is my experience. Okay. Now server error is the same. It can return mock the server error. It will do the same thing. So let's run this. It also will have retry and will have a server error. Okay. Now let's see this. Okay. So find age and find age again. Fallback with say 500 server error. Right. This is error message. With a server error. So it will be catched by the retry. Okay. Now this is about the retry test. Now next, I especially want to test the circuit breaker. Circuit breaker. So circuit breaker from the YAML. So it says you can try 3 times if the failure rate is 50%. Right. So you have to fail twice. It will be in open status. It will be open status. Now, how to test? I build this test case. The other is the same. That's starting from the name service. So I can use a server error or timeout, whatever. Okay, you can use this server error. Now, at the beginning, okay, we can assert the state, okay, dot closed is server get state. So at the beginning is closed. Okay. Now we have first call. Let's make it bigger. After the first call, and I want to verify it will call twice. The reason is we have 2 retries, so we have to call twice. Every time I retry, I will call this service once, right? So I have twice. And after that, the state is still closed. So after the first call I fail, the state is closed. Then I go to the second call. After the second call, I still have 2 retries. So totally I have 4 retries, right? 4 calls to the external service. And after the second one, even the second is failed, I still close because the maximum bucket, the buffer size is 3. I have to finish 3 times, and the system will calculate how many fail rate, right? So this is still closed. Okay. Then that's the second call. The third call, right? Like we reach the buffer size. That is the ring buffer size in closed state is 3, and then I check the failure rate is 50%. Now I will go to third call. After third call, I will also have a retry, and so there are 6 times. There are 6 times. 6 times of call to the external service, and this time after 3 calls, breaker enters the open state status. The reason is during the 3 calls, you fail all the 3 times. It's greater than 50%. It will be in open. You can make the fourth call. In the fourth call, you won't see any call to the service part. It won't call service. That is, the log will not be there. Then you verify it still call 6 times. Okay, it means even if you call the 4th time, the calling to the external service doesn't change. It's still 6, right? It's still 6. Then it's still in the open status. Then after that, I reset. Reset it will go back to the closed status. Then if I call it again, then I have 8 times, right? I will another call to that one. Then finally, the status is internal server error, so the circuit breaker will reset. That's the whole picture. Okay, to test the circuit breaker. Let's run it and let's see. Let's see the logs to prove that. Okay, now let's start from beginning. The very beginning. So the first call, this is the first call. Find age, I call twice, then go to the fallback. Okay, then we get the internal server error, name exception. That's the first call. So I call twice, right? So the verify is 2. That's the first call. Then the second call, find age, receive a request. That's the second call. Another fallback here. That's the second call. So I call the external service 4 times. Okay, that's the second call. Now the third call, again find 6 times, right? Then go to the fallback. That's the third call. So now next is fourth call. Okay, the fourth call it says the circuit breaker, common circuit breaker is open and does not permit further calls. So you cannot call it anymore. So it means that this method, the controller, info receiver request with name, this one will not be printed out because this call get by name. This call is already in the state, in the open state. This call is not allowed to be called anymore. This method is not allowed to be called anymore. So this is from the from this one. Circuit is open and does not permit any further call. So for other logs, for all the other logs, you will first receive a request, then find there are 2 find by H, then fallback. There are 4 lines, right? But in the first call, it has no log at all. It just say common circuit breaker is open and does not permit further call. It means on the external service, the traffic is very high. So at this time, don't call it anymore. And then after that, I will make it open. I will make it close. The fifth call, I will reset it. After I reset it, it's closed again. I receive a call and another one happens, right? And finally, it's finished. So if you like, you can try another one that is for the reset part. You can say reset, right? If you don't say reset, I can delay for so let's say delay 50 seconds. Delay 50 seconds. Let me change a little bit. Delay for 5 seconds. Let's say 5 seconds. Okay. So this is wait duration, right? 5 seconds. So what I do is in this text, I can change it to try thread.sleep. Sleep 6,000. I just make more than that. Catch exception. Okay. So let's wait for 6,000 or 6 seconds. So the duration is more than this duration. Okay. It means after the 5 seconds, it will go back to the closed state. It won't. I don't have to manually reset it. So it will automatically go back. So let's run it again. Okay, now here I wait for a while. Wait for 6 seconds. What happens? But it's open or it's not coming back. Actually, I think it should be coming back. It's still not permitted for further calls. It's open, does not permit for further calls. So something is wrong after I wait for this time. I was tested before for this one. Let's skip this. Maybe I need any time for further research for that. Now, at least if I reset, it's closed. So by my understanding, based on this configuration, after this duration in open state, it will go back to the closed state. You don't have to manually reset it, but what our test looks like doesn't match this case. That's a different story. But anyway, so some details need to make to be made with the further research to make all cases work. And also, if you have interest, you can also build a test case for rate limiter and the bulkhead. So that's pretty much for today's topic with the resilience 4J and with the WireMock. Okay, thank you.